Hello, everybody. My name's Colin. Thanks for coming to this talk. I'm excited to be here. As a web developer, it's been kind of exciting to sit in on all the data science talks and see all the amazing projects that everyone's been working on, and kind of gives me something to strive for as I can do some stuff like this in Python. So yeah, I'll be speaking about a project called Open Data Policing. And it's a web app. It aggregates and displays traffic stop data, and it includes some visualizations to help visualize and sort of step through that data. And currently it's for North Carolina, but we're planning to release it in Maryland shortly. And the talk, just as a high-level overview of the talk outline, the first half I'm going to spend primarily talking about the background of the project and some info on the North Carolina data collection law. And the second half I'll talk just about how the site works and give you an idea about that. So again, my name's Colin. I'm CTO at Cactus Group. Organizations turn to Cactus for Python and Django development done right. Since 2007, our business and social impact solutions have reached over 70 million people. Please stop by our booth to learn more about Cactus. We're right outside the door here. We're hiring. You can see a demo of this site, and we're also raffling off a copy of Lightweight Django, which Mark, our technical director, is here, and he'll be giving a talk in the next session. So you should stop by. I'm also co-captain of Code for Durham, which is a Code for America brigade here in the Triangle. This is a picture of one of our hack nights at our office. Co-captain Adam there is up in front of the room. And basically, we build apps for the community. We built a variety of apps so far, including like a restaurant sanitation score inspector. The most active one right now is an app to help navigate the Durham public school system. And so we're just a collection of citizens who volunteer their time to work on apps and help improve Durham. And that's kind of why I helped start the group, and I like the idea of just working with community members on projects. And so when Ian approached me about this traffic stop project, I was pretty excited. He's an attorney with the Southern Coalition for Social Justice, and this project is his idea, and he has and maintains the vision of it. And so that's a caveat. I'm not a lawyer. I'm not a statistician either. I'm a developer, and the team here we kind of helped bring this project to the web so that it's more accessible. And so a lot of the information that I'll touch on at the beginning of this talk is from him, and I'll kind of summarize it at a high level. But basically, Ian wants to use this traffic stop data to help promote equity in policing and make it more accessible both on the departmental level and the officer level, and put it on a website. And so initially the group was fairly small. Andy and Dylan helped out. Andy's in the crowd there. So we were all entirely volunteer. We worked on nights and weekends, and we're just kind of excited technologists who believed in what Ian was working on and wanted to help folks in North Carolina. And so the site is divided into 3 features. There's an agency dashboard, which aggregates and displays stops, searches, contraband hit rates, and use of force data all over time. And the officer dashboard is the same set of graphs, just sort of narrowed down to the officer level. And then there's a find a stop feature, which allows you to basically search through the entire data set and look for a particular stop based on some criteria. In fact, you can pull this up right now. The Phase 1 site with North Carolina is online. It's at opendatapolicingnc.com. Feel free to navigate around. A lot of what I'll demo today will show a bit of the second phase, which is currently unreleased and what Cactus worked on. But this site has the latest North Carolina data that we have. And so I'll talk a little bit about that site right now. So North Carolina was the first state in the country to have this type of statewide data collection law. It was enacted in April of '99. And so it requires almost all police agencies to record and track traffic stops, and then they're centrally collected at the state level with the DOJ. The law grew out of a scandal that was around a drug task force in Cumberland County, They discovered a 2-to-1 search disparity for narcotics officers, but realized that the contraband hit rate was equal among races, and yet black drivers were being searched twice as often. And so basically how they structured the law is that anytime a police officer stops someone in North Carolina, they fill out this SBI 122 form, and you can see all the fields. There's like 45 boxes on this form, and some of it's digital now, like in the officer's car. They can fill it out on their computer, but it's also paper in some counties still. But you enter like the county of stop, what was the purpose of the stop, the age, the race, ethnicity, whether or not led to a search. Lots of information is in here. Like an interesting point is that the officer is kind of making the determination here, and it's probably true that they don't always get it right, but it's the general consensus in Ian's world is to not have the officers who just made the traffic stop to start asking what like race and ethnicity you are, and kind of consciously injecting race into the conversation. I think as the driver, you'd probably be like, why are you asking me that? But in the end, officers are making these traffic stops, and I think it's an interesting aspect to the policing culture, and like hopefully this data transparency will be helpful to them and others, and just help them be aware of what their stopping patterns. And so the officers give this data to their sergeant, and then that gets reported up to the state every month. And obviously not all stops result in searches, but over time we have a good sense of these because we now have 15 years of data statewide. And so, it's not just it's not a snapshot, it's a portrait of like all reported stop activity and searches statewide. And another interesting note about the statute is that as far as we know, no one really looked at the data for at least 10 years. We're not really sure why. Maybe because it's kind of a lot of data. It's not easy to kind of just download it and open it up in like Excel or something, but Ian met a professor at UNC when he was in law school, Dr. Frank Baumgartner, who he worked with a race and justice commission, and they kind of realized just how powerful this type of data can be in the policy arena. And so when he analyzed it and noticed significant racial disparities, particularly with searches and use of force, he found that the average North Carolina officer searches around 3% of the people that they stop, which is about 1 in 33, but that there's a pretty wide variance from jurisdiction to jurisdiction. Sometimes you'll find some cities that 1 in 6 black drivers get stopped, or sometimes you'll find individual officers who will stop like 2/3 of all, or search 2/3 of all the drivers that they stop for years on end, and do so with only like a contraband hit rate in the single digits. And so based on Frank's findings, Ian just had this idea to make the data more accessible. Like if we can put it on a website, then it can sort of help lead to promoting more equity in policing. And so I'll touch on 2 target audiences, public defenders and police agencies themselves. And I'll use some examples while hopefully trying to demo the site. And so the law as written, it allows data to be used for any valid claim or defense, and it's currently being tested. And so the first example here is an attorney from the Orange County Public Defender's Office reached out to the Southern Coalition, and she had a client who was arrested with a large amount of narcotics in his truck. But the story of how they were stopped and searched was a little unclear, and the attorney noticed that she sees these 2 particular officers more frequently when she's representing Hispanic defendants. And so after some back and forth with the judge, she got a court order to release the officer IDs, and they plugged it in the website. And what they found is that these 2 officers accounted for 60% of all the Hispanic searches in that county for the previous decade. And this is in a county whose population is only about 8% Hispanic. You can see the census data there for Orange County, North Carolina. All right, so I will try to do a little quick demo here. And so when you pull up the site, you get to see the 2 states that we currently have, both North Carolina and Maryland. And when you can drill in, And when you get to the state homepage, you're presented with some options to drill into like the various agencies, but also you can click on find a stop and search for stops there. And so for here, we're just going to look for the Orange County Sheriff, and so you can type it in and bring up the first primary feature of the site, which I talked about earlier, is the officer dashboard. And you can sort of scroll through here. We have stop percentages by race and ethnicity, all the way down to search percentages and contraband hit rate. So it's all this data over time, and you can kind of browse through and look at it. And I do want to note that there's this toggle up at the top, which allows you to switch between race and ethnicity. Obviously, they're different. They're recorded differently. We can't do a black to white to Hispanic driver comparison because it's a factor of how they're recorded. So we can flip back and forth here to sort of look at the data sliced in a different way. But yeah, so if we just look at the top level, it's not on par, but it's fairly close. It looks like they stop around 10%. 10% of the drivers stopped are Hispanic. And so it's kind of in the ballpark of what the demographic makeup of that county is. But if we scroll down and look at the departmental search rate, it is fairly high, especially when we're considering like the average North Carolina officer searches around 3%. So here we can see in 2010 that they were searching 23% of Hispanic drivers. So it's kind of like a high number, and something we kind of want to drill into and look at. And so what we can do is come up and click on Find a Stop up here. And it presents us with a form where we can drill into the data and look at it. And so we can type in the Orange County Sheriff's Office, enter this officer ID that we're going to look at, and we get the results of the search results for all this officer over time and all their stops. So this is that second primary feature that allows you to kind of drill in and look at the data. If you click on the officer ID, we'll be able to see the officer dashboard. And so if we look at this officer, it's pretty interesting. You can sort of see there are some really high search rates, but still way above the average even later on down here in 2010. And if we just look at searches, you can see that for several years on end, they were searching more Hispanic drivers than non-Hispanic drivers. And again, this is in a county that's only 8% Hispanic. So the public defender took this data back to the judge, and eventually the man who was facing life in prison was offered a plea deal. Obviously, the point here isn't that we should use this technology to help criminals get away, but the reality is that in order to sort of change the policing culture and promote equitable policing, that a database approach can be really powerful. This was the largest drug arrest in the county for that year, and it was a big deal when it got thrown out. And it affects a lot of people, even the police chief, and when it likely could have been mitigated earlier on. And I think in this case, the data transparency kind of identified an issue from outside the department. Like it wasn't seen early on, but this allowed like the public defender to kind of look at it and sort of say something that doesn't look right. So it's nice for to have that accessibility to the data. And so ideally, if this happens enough, more people will see the value of this data. Before I touch on the next target audience, I do want to talk a little bit about using this data responsibly. We do stress that everyone should kind of be mindful of how they use the data. It doesn't always tell the whole picture, and we only sort of analyze it in certain ways. You don't want to just say, oh well, like 90% of this officer's stops are black or Hispanic drivers, because you kind of want to know more about that officer, where they're assigned. They could be assigned in a neighborhood with that demographic characteristic. And unfortunately, we don't have, in the statewide data set, we don't have any more granular locational data. We just know that an agency made a stop. We don't have like a street address or lat long, so we can't mash it up with like police beats or anything like that. But so yeah, so the idea isn't for an attorney to just like print up the website and use it without additional research. And we're also kind of intentional in how we display the data. We're not trying to like rank agencies or offer a score or anything. We're kind of just presenting the data as is. Another part of the site is for police management. This is Fayetteville Police Chief, Chief Medlock. And this kind of ties back to the data not being reviewed for over 10 years. Police agencies themselves weren't really looking at the data. They would just kind of like record it, report it, and send it up to the state. And Medlock's idea is to use this as a diagnostic tool so that chief can log on, see what their department looks like, see and go and look at individual officers. There are no names on the website; those are protected by law. And to get from name or from ID to name, that you have to have a court order, so that's all protected. But the chiefs, they know their officer IDs, and they also know where their officers are assigned, so that they have a good insight into this. And so they can instantly see the career enforcement history for their officers, and bring this up in annual performance reviews and look at it. Generally, the idea around this is fairly mixed. Ian showed this tool at a White House event, and in a room that's full of a lot of big city chiefs, and the room was pretty divided, about half and half. I think there are a lot of opinions out there of the value of having this data be accessible to the public, but I think there's this growing realization that this is kind of the future, and that it's being more transparent is that builds trust. And so I want to show off another feature by looking at the Fayetteville data, if I can find it. So yeah, Medlock was brought on in the wake of a profiling-related scandal at the end of 2012, and he noticed that most traffic stops were low-level technical type stops. And in fact, this is kind of common across most agencies, that the smaller the technical offense, there's more discretion is exercised by the officer. And so you can see, if we sort of look here, overall Fayetteville is going down, which is nice, especially after after Chief Medlock joined the force. And what he kind of noticed is, in this graph we like to talk about a lot. So these are all of these bars here are kind of in this example in comparison to white drivers. So this example is all black versus white drivers here. And so what he notices is that, for an example, with a DWI, there's little or no disparity because there's always objective evidence, take a breathalyzer, or they're swerving all over the road or something. But for a seatbelt violation, historically in Fayetteville, black drivers have been 110% more likely in the course of a seatbelt stop to be searched. And so, it's a pretty big disparity. And again, the question is kind of well, if they are seeing these disparities, are they actually finding more contraband in the end? And the answer is usually no. You can see here they're pretty close of the contraband hit rates, right around 25%. And in fact, Frank and SCSJ kind of reviewed this data over the past 10 years and have found almost no difference. It's about a 19% hit rate across for both black and white drivers. And yet, black drivers are usually being searched more often. So yeah, that was an overview of how the site is currently being used, and I'll talk a little bit now about how the site works. This is a high-level overview. Oh, probably be useful if I turn my display back on. There we go. This is a high-level overview of the site architecture. You can sort of see we have the browser on the side all the way back to our database. And so yeah, the front end is a mix of Django and JavaScript with D3 for the visualizations and Backbone to kind of communicate with our API. And we have a Django app that stores all of our business logic, including the modeling for the data, and then an API that aggregates it all. And it's all stored in a PostgreSQL database. And so again, we have all reported traffic stops. That's a 100 counties in North Carolina, 314 agencies. It's everything from the State Highway Patrol all the way down to like the University Police Department. We have over 20 million stops, and nearly half of those are for the State Highway Patrol. And here you can see a high-level snapshot of the schema of the data that we have. So we have like the agency, an ID. Again, it's anonymous. It's not even their badge number. It's just an ID that they use for reporting. When the stop happened, the purpose of the stop, what type of action was taken. For every stop, there are one or more related people. So you could have a driver and/or a passenger in the car, and then that table contains their demographic information. So their age, their gender, race, ethnicity, and then if a search, we have some search data too. If there's a search happened, then we have some information on that as well. And so we get all of this data from the state. It's obtained via regular FOIA request, and they send us CD, which when it's uncompressed, it's about 5 gigabytes of tabular data. It's all stored in a Microsoft SQL server on their end, and so we know that they kind of centrally maintain the data, which is not something we're certain about with Maryland, which I'll talk about. And it's the full data set each time. We're not receiving like just since we last made the request. And so what we do is we just store it on S3 and import it using our ETL process. And so it's a large data set. We don't really know what changed. Like maybe there was an agency that was behind in reporting. That happens a lot. We do it every month, and they may not report it for a couple months. And so we don't want to like miss anything. Or if somebody updated a row, that we wouldn't want to miss that. And so it's easier for us just to kind of re-import the whole data set each time we get it. And so this ETL process is designed to be, kind of atomic and repeatable. And so what we do is we just download the latest data. We do some cleaning, which in North Carolina we don't really do anything. We just convert it to CSV and import it in the database. We can't really use anything like Django's bulk inserts here because we'd be instantiating like 40 million objects, and it's not really that efficient. And so we just convert it to CSV and use Postgres's copy command to load it into the database. You can see here on how we get it in. It's all within a single transaction, so we just truncate all the tables that are there, run the copy command, add the constraints back and indexes back, and then commit it. It's kind of nice if anything fails, it just automatically rolls back, and the website has all the old data that we had before. So yeah, we have 40 million rows across both the stops and the people tables and searches. The entire process runs in about 30 minutes. A lot of that time is just kind of unzipping it and converting it to CSV, but there's also a lot of time in the database as well. But once we get rid of the indexes, our inserts are relatively fast. We can get about 21 million in 88 seconds. And this was an early scaling issue for us. It's not the largest data set ever, and we don't really need massive scaling for this site, but it was kind of fairly sizable for our little team, and we were trying to figure out how to make this work, and especially when you're running this on like a small EC2 instance on a budget, the imports would kind of end up taking hours, and so that's why we did this method of dropping all the constraints and indexes to make it load faster. And so all of this data now is loaded into its own Postgres database because we wanted to think about how to sort of plan for the future and add more sites. And so we're adding Maryland right now, and this means not only updating the design and the UX of the site, but also being able to model it differently as well. And so each state has its own Python and Django app, and we chose to sort of normalize the data at the API level. So the graphs and the backbone code can kind of all expect the same general schema via the API, but behind the scenes the data can look a little bit different. And this is nice because this will allow the sites to have some extra features. Fayetteville provided some geolocational data, and so we're looking to add that type of data to the North Carolina site. A lot of Cactus's work was sort of in this abstraction piece here and trying to make it easier to extend and customize. And we use Django's database routing to kind of like figure out which database we should talk to based on the type of requests that we're making. And currently this all just runs on a single Ubuntu box in the cloud, but it could easily kind of be split up down the road if we ever need that type of distribution. And so now we have this Maryland app, but the Maryland data is a different story. It turned out to be very different and far less accessible, and it took Ian a really long time to get a working copy of the data. I'm kind of amazed how easy it is in North Carolina. And so basically we would get different dumps every couple of months, and they would be different. We would have like no officer IDs or no agency names, and so it was really hard to figure out like what we were working with or what they were sending us, and it wasn't normalized at all like it was in North Carolina. Here's one of the data dumps that we had. It's kind of like spread across like all these different Excel files in different years, and the years would have like drastically different numbers of agencies in them. And in these files themselves, there would be vastly different reporting formats. So it was, I don't know. Maybe they don't centrally collect it and analyze. We don't really know why it was this way. Maybe they're just giving us the raw data that the officers and the agencies report up to the state. But it just simply wasn't as easy for us to get it in. Finally, we got 3 years of data. Still took a lot of cleaning to get it to work. Even down to like the time field, you could tell it was kind of hand entered, or even when it was transcribed, we'd just have times that made no sense, and that was just across all the fields. So a lot of cleaning was involved, and one area where like in North Carolina we have these stop reasons that are kind of categorized for us, so like a seatbelt violation or vehicle regulatory violation. But in Maryland, we actually got the individual code number, which is actually kind of interesting. You can really, it's very detailed. You can see, so the codes are on the side here, 13607E, which is great. But if the officer's kind of filling this in by hand, there's just like tons of errors that happen. And so what we would do is just kind of clean it up with some regular expressions and then map them into categories. And we didn't do this. The Southern Coalition did. They reviewed the statute and the law, and we'd provide them a CSV file, and they would just sort of map up the statutes to the categories and get everything appropriately organized. That's the CSV file there. By the way, all this code is open source on GitHub, which I'll have a link to at the end. We also did this with agency names. Maryland didn't give us any names. We had a bunch of agency codes, which were hard to decode. And then we also wanted to introduce this idea to provide a sort of reference demographic information from the census. And it's not always clear to sort of pair the agencies to a particular census ID. It's kind of easy to match Aberdeen Police Department with the city of Aberdeen in the census, but cities within counties can have like widely varying demographics, and when you're looking at the census, the county demographics include the cities, and so you can't always accurately pair like a county sheriff with the county demographics because those demographics may be heavily weighted by the city where the sheriff doesn't usually police in. But you can in some counties, and so again, the Southern Coalition kind of looked at this and picked out IDs that we have a census. We just like ping the census API and pull in all the data, and then they match it up with the census ID. All right, so I wanted to show a little bit about our API. Okay, so this is Montgomery County in Maryland. And if you come up here and just look at our URL, it's an agency of ID with 80 there. If we just add API to the URL, you can see we get our sort of API browser. You can see the data that's returned, and it includes the census data that we were talking about. If you add stops to the end of that URL, we get all the stops aggregated by year for the by race and ethnicity. In Maryland, they report it differently. Hispanic drivers are just reported alongside black and white, so you can see it mixed in here. And so yes, this is what D3 uses to draw these graphs. And they're not really complex aggregates. They're fairly simple to do. But given the data set size and like with the State Highway Patrol, it's 10 million stops being aggregated when they click on the page, and so it's intensive for that brief moment and can be kind of time consuming. Luckily for us, it's all read-only data. It never changes once we import it, so we can just kind of heavily cache it, not really have to worry about that. And we use a Django cache machine for that. So yeah, Maryland is a much smaller data set. We only have 3 years so far. The Southern Coalition is still kind of analyzing it with us, and we only have about 2 million stops. And we weren't able to normalize all the stops. We just had some bad data that we didn't really know how to deal with, and so we had to discard about 1% of it. But the biggest discovery that we ran into is that Baltimore wasn't really following the law. And I should also bring up my, there we go. Yeah, so we saw that Baltimore data was in the data set, but it was missing a lot of fields. Here you can see how it's kind of small on the screen, but that's all Baltimore Police Department. But you can see there's a lot of empty cells. We're missing a ton of data, including the date, and whether or not there was a search, who was the officer, and they give a lot of sort of some excuses around it, just like there was no data, there was a corrupt server, or I think Maryland's structured a little bit differently, that they aren't required to report it some years, and so some agencies just choose not to report it. So we didn't have data for 2014 and 2015, apparently. And so Ian actually took this data back to Maryland, and just this week, Baltimore kind of admitted to this fault, and so I think they're going to plan to figure that out together. And so yeah, that was a pretty interesting discovery. And lastly, I wanted to give a quick overview of just it's a fairly simple data set, but I wanted to sort of show you what we did to get the officer or the departmental search rates. And so I kind of preloaded some data here from our clean data from Maryland. And so if we look at the data types in this data frame, you can see we have the time and agency name. And this is all stop data, so and it's all driver data in Maryland. So we have the age, race, and ethnicity of the driver, whether or not a search was conducted. So you can kind of peek at the data here and see that these are the different agencies, whether or not a search was conducted here, the stop reason, those codes that we cleaned up. See, we have about 2 million stops in this data set, and if we just look at them sort of grouped by the agencies, you can see that the Maryland State Police is the largest, and Montgomery has about 227,000. And so I wanted to drill in here to Montgomery County, and so we just filter down by the agency description. This is all in pandas, and make a new data frame just for Montgomery. And then we want to sort of aggregate this information by the year and the year and the race. And so we're going to use the date time and the year there, and the ethnicity, which is the name of the column here. And so we'll do a group by in pandas and do a count on those, and then we get this aggregated data frame back of like in 2013 there were around almost 17,000 black drivers were stopped. And we want to compare this to the searches. And so what we can do is just look for where a search was conducted and do the same kind of grouping, and we'll get all of our searches here, obviously smaller numbers. And then in order to compare them, we want to merge the data frames together. So we combine them using this merge command and get them all and merge them on where the date time and the ethnicity fields matched. And then we need to get the search rate. So we just take all of the searches that we have and divide it by the stops, multiply it by 100, and we get a rate, the departmental search rate by year, basically. And then we can pivot this table so that our columns are the races, the dates or the rows, and then it makes it relatively easy to plot this on the map, on the graph. And so that's how we're more or less doing it in SQL. But this is a visual example here in Jupyter. And that is the whole talk. Thanks for coming out. The code is online there on GitHub, Open Data Policing NC. And yeah, are there any questions?
You obviously mentioned Maryland, but I was curious if you could talk about other states that either have laws in effect to collect this sort of information, or other efforts that are similar to this to try to publish the information.
Yeah, there are only a handful of states that do it. We know that Rhode Island and Connecticut, and we recently just received the data set for Illinois, which we're kind of excited about because it has Chicago in it. But I think that's really about it. I know that California just enacted one last year, so it'll take a while to get any kind of longitudinal data for that. But there are only a handful of states in the country that do it.
Okay, so this just goes to the underlying quality of the data. The racial and ethnicity data are being self-reported by the officer, correct?
That's correct.
In a way, it occurs to me that you may be lucky that no one's looked at this data for 10 years because your self-reporting hasn't been influenced by results. Mm-hmm. So my question is there some kind of cross-validation that you could do to ensure that the self-reporting matches with the actual race or ethnicity of the individuals? For example, if someone is charged with a crime, you probably could go back and get that data. And is that in the works, or is that something you've thought about?
That's a good question. Yeah, it's not really something that's going to be a feature on the website. Obviously, if you were stopped, you can kind of search yourself. Like you could look for, say that this agency stopped me, drill it down to a particular day, and kind of see how they reported you. But like you were saying, yeah, like if a public defender or an attorney is kind of looking at this data more frequently, then they would be able to kind of compare that too. We don't really have a way to like do that holistically across the data set, obviously, but I think it's an important or an interesting idea.
So then you said that contraband hit rate was not different for different races. Mm-hmm. What was it % off?
Between the races?
You said that it was around 25% for each race. What was it 25% off?
Oh, sorry. So yeah, so like the SCSJ, when they looked at that historically over 10 years, they found that the contraband hit rates were about equal, and I think that was about 19% of the drivers that they searched had contraband, and that was equal between black and white drivers.
But if it's 25% for each car that was searched, and they searched some races more than others, isn't it that actually there is some sort of imbalance?
I don't know if I understand the question. What do you mean? So, take it offline. Sorry.
All right, we're going to have to do a quick room change. So we have 5 minutes until the next talk starts. Thanks.